So we are on with our last topic of the semester. Essentially, it's just going to be a bunch of generalizations of the fundamental theorem of calculus to a lot of cool situations. So before we do that, let's just remember what the fundamental theorem of calculus is from Calc 1. So remember there are two parts. One part says that if f of x is equal to the integral from t is equal to a can be any number, to t is equal to x, of the function f of t dt. So we have the capital F and the little f. And here we need to make assumptions like f is continuous or something along those lines. F is a nice function. That's a term that will come up throughout the rest of these lectures. Basically, you can just think of that as meaning continuous. Then what this tells us, what the fundamental theorem of calculus says, is that big F prime of x is equal to little f of x. Okay, so this is one part of the fundamental theorem of calculus. The other part says the following. It says if f prime of x is equal to little f of x, then f of b, big F of b, minus big F of a is equal to the integral t equals a to b f of t dt. And here in this integral, we could have done it with the x variable instead of the t variable, but none of that matters. Okay, it's just notation. So this is the fundamental theorem of calculus from Calc 1, and basically all of the other theorems are generalizations of this, or all of the other theorems we're going to learn in this class are generalizations of this, and the proof basically comes back to the fundamental theorem of calculus.